Okay, so I guess I'm audible. So today we will start with something called as strings. Okay, so we will be doing some basic problems on string, and then we will move on to some advanced problems. Okay, so let's say first basic problem, what it could be. Let's say you are given in string. Okay, you are given in string, and the length of string could go up to 1000. Okay, or let's say 10 raised to power 3. The constraint is this, and also you will be given something like either you could have small letters, all are small letters, or capital letters, something like this. Okay, so you will be given that. Okay, and the first question is that you need to print all the substrings. Okay, you need to print all the substrings. Okay, so I guess that is very easy. Okay, so let's try to write the code for the same. Okay, so what you need to do is, let's say you have a string s. Let's say you have a string s. You need to take this s as input. Then let's do one thing. Let's create a set of type string, and let's name it as st. Then let's say int n equal to s dot size. Let's take the size of this string. Then let's run a for loop for, let's say, int I equal to 0, I less than n, I plus plus. What I want to do is, let's take a sub str of type string, of course. So I'll write a string sub str, and it would be an empty string. Then I'll say for let's say int j equal to j less than n, j plus plus. So what I'll do is sub str plus equal to s of I, right? So this way I'll be able to get all the substrings, and then what I'll do is st dot insert sub str. So obviously it's a set. Okay, so we will be getting all the unique substrings only, right? So we will be getting all the unique substrings only. So let's try printing these. So let's say auto it colon st. So I want to see out it, and let's say this. I guess I'm not missing any semicolon or something. Okay, so let's give some input first, and let's see if it prints all the, yeah. So you can see basically it will print all the subsets, right? So sorry, substrings, right? So this way we can print all the substrings, but there is some problem with this server. Okay, let's find out what. There's one silly mistake. I guess it should be j here. It should be j. Yeah. So now I guess yeah, now it will print all the substrings. Okay, so now let's try calculating the time complexity of this. Okay, so just let me do this in sketchpad. Okay, so as simple as that. So we have a outer for loop, right? So we have a outer for loop, we have a inner for loop, right? So then we have a insert operation. So this is, and this is, and so the insert operation takes log n, right? So it will be n square log, where this n is the number of elements in set, right? So that will be up to 10 raised to power 6. And also one more problem is here. Let's say you have this set, right? So we will be having up to 10 raised to power 6 elements, 10 raised to power 6 substrings in this set, the maximum we can have, right? And the size of one some substring could be, it could be 1, it could be 2, and it could go up to 1000, right? It could go up to 1000. And on an average for all the substrings, let's take the length as 500, right? So we have 10 raised to power 6 strings, right? And we have a length of 500 for each. On an average length we are assuming here, right? So what will happen, it will give something called as mle. That means memory limit exceeded. So what we need to do is, we need to now make this algo some efficient, right? We need to do something. So to solve this problem, we have something called as rolling hash function. Okay, so we have something called as rolling hash function. So we will be using that. So what we say in rolling hash function is that we will convert our string into integer. Okay, and the conversion formula could be of our own choice. It could be of our own choice. But what we will do is we will convert our string into an equivalent integer. Okay, so let me give you example of some formulas, right? Let's say we have a, right? Now the sky value of a is 97. So let's say what I say is it's a summation of si. Let's take the summation of si for all the variables. Like let's say we have a, b, c. So a is 97, b is 98, c is let's say 99. So let's create a formula for abc substring. Its equivalent integer will be 97 plus 98 plus 99, right? Then let's take bcd. So b is 98, c is 99, and this is 100. So the summation will be 98 plus 99 plus 100, right? So this could be one formula, but there is some problem. What could be the problem? That there is a possibility that this sum for multiple strings could be equivalent, right? So let's say you have a string abc, then let's say you have a string bca, right? So now the equivalent formula for abc and bca will be same, obviously, right? Because we have bc and a, right? This is something that we don't want, right? This is something that we don't want the same equivalent formula for different strings, right? And even there is a possibility that there is a complete different string, let's say d a or something, and it comes out to be the same integer value, right? According to this formula. So one way or another we need to create a formula. So that their equivalence won't interfere with each other. Okay, there should be no intersection between these integer values. We need to decrease this probability, right? We need to keep our formula as complex as possible, but it should be in limits, right? So that there should be no tle as well. So let's try one thing. Okay, so what I want to try is the respective this value. So what I'll do is I will multiply it with 31, and with index 31 raised to the power index. Okay, so let's say for abc, what I'll do is if the index, let's say, is 0, so I'll multiply a with 0. Then what I'll do is I'll multiply this b, so that is b. So the equivalent value is 98, right? So for a it's 97, for a is 98. So I'll multiply it with 31 raised to power 1. Similarly for c it's 99, I'll multiply it with the power 31 raised to power 2, and so on. So if I do have a long string, right, so I'll convert it into integer. What I'll do is I'm taking 31 because 31 is a prime number, and if I'm going to raise it to some power, let's say 1 2 3, and let's say if the length is 12 or something, so 31 raised to the power 12, though this value may go very long, so we will take a mode as well, right? And the mode value will also be like 10 raised to power 9 plus 7, right? So there will be like very very less chances that there will be same equivalent value for two different strings, right? So the probability will become 1 upon mod, up to 1 upon mod, and that's a very good probability that there is very less chances that two strings are going to have the same equivalent. But let's say if still we do have a equivalent, so for that purpose also we have a solution. We will talk about just in a while after covering the algo. So now let's try writing the code for the same. Okay, so let me comment this thing out. Let me comment this thing out, and also let me show you some stuff, right? So even instead of the sky values, instead of the multiplying the xsky values, we can have the corresponding 1 2 3 values, because with sky value the value may go very bigger, right? So it may create a problem. Let's create an equivalent values. Like let's say for a I'll multiply it with 1, for b I'll multiply it with 2 3 4 up to 26, right? So we can do that as well. Let's say if I want to convert to that equivalent, so what we can do is, let's say we have a, and if I do a minus a as well, and then I'll add a plus 1. Okay, so basically what it will do is it will give me 1, right? It will give me 1. So it will give me 1. Let's say if you have C, so it will give me 3, because for C the value may be whatever it is. So A is 97, I guess C is 100, so 100 minus 97, and it will do a plus 1, so it will give us 3, right? So we can let's say if we have a string S, so we can do a SI here. We can do the ith index of string S, and then what we can do is we can subtract a minus A, and then we can add a plus 1, so it will keep giving us the equivalence. Okay, so it will keep giving us the equivalence. Okay, now let's try writing a function. Now let's simply try writing a function. So what this function will do is, let's say it's a this function will simply return a integer value. So let's say int, and let's name it as fn. It will take a string S, and what it will do is it will return us the equivalent hash value, because this algo is called as hash rolling function. So we can call it as hash value, right? Let's say it will return as hash value. Then we will pass a p as well, because this 31 is not compulsory, right? So this value could also change. So instead of 31 I'm passing p. So whatever be the p is, I'll multiply it with that number, right? I'll multiply it with that number, and then I'll also pass the mode value as well. I will also pass the mode value as well, right? So now what next we need to do? We need to simply apply our formula. So let's take this. Let me write here int. Let's say n equal to s dot size. So we have s dot size. Let's say hash equal to 0. Initially we have the hash value as 0. Then I'll simply run a for loop. Let's say int I equal to 0, I less than n, and then I plus plus. So what I need to do is I'll say hash equal to hash plus 1, hash, sorry, not plus 1, hash plus. What I'll say is, first of all I will find the equivalent 123 value. Let's say if we have ith index of our string, so I will do a minus A and plus 1, so I will get like the equivalent value, whether it's 1 2 3 according to the string particular letter, if whether it's A B C or D, right? And then what I'll do is I will simply multiply it with power, right? So I will multiply with it with the power of p raised to power I. So let's say if p is 31, 1 raised to the power I, right? I will multiply it this way, and then what I'll do is I'll take the complete mode. Then I will take the complete mode, right? So this is what we are supposed to do. So, and also, as we talked about earlier, this power function of STL takes more time, right? So we have this mode power function. I'm just copy pasting it because we covered it in a separate lecture. This is as per the binary exponentiation. Okay. So let's do one thing. Instead of using this power function, let's use this mode power, right? So let's use the mode power. So let's use the mode power. And in mode power, what we need to do is we need to pass the mode value as well. We need to pass, I guess, three variables. Yeah, base, n, and mode, right? Also, this power value could be very large, right? So, and this s value, this overall value could be very large. So let's apply the multiplication rule as well. So let's take a mode here as well before this one. And then we are taking the overall mode as well, right? So this is how our hash will look like. And then we simply need to return our hash. So then we simply need to return our hash, right? So this is my fn. Now let me do one thing. Let me copy these two lines, and let me just paste them. So what I'll do is I'll take the s as input, and let's try c out. So I will say fns, right? So let's see if it's converting the string into the respective hash or not. Okay, so we have an error. Okay, let's see what the error is. Okay, so we obviously just need to pass the p value as well now. So let's say p is 31, and we need to pass string p value and the mode value. So that is 1e9 plus 7, right? So let's say hopefully it will work this time. Okay, it's taking time. Why is that happening? Okay, so basically let's add some input and let's just try in running the code, right? So it's basically printing the hash value, right? So we will be optimizing this hash function as well. Right now it will take a little bit more time, right? Though it is getting like it's good, but we will be modifying this hash function more, right? Because it's not still that much effective. So we will be make it this hash function more efficient. But I think you got the basic idea, right? I think you got the basic idea that you are given a string, and you, according to your own formula, it could be anything, and you are converting it into an equivalent integer, right? Let's say sdf, the equivalent integer for this is this, right? So this is the basic intuition behind the rolling hash function, right? So now what we can do is we can further uh, make this rolling hash function more efficient. So first thing is, instead of calculating this power again and again, right? Instead of calculating this power again and again, what we can do is we can let's do one thing. Let's take a variable pr, right? Let's take a variable pr and let's save a value 1, right? So what we will do is, instead of using this power function, what I'll say is, instead of power, I will say here, so PR multiplied by P, right? So whatever be the P value is passed, and or I'll simply use PR only here, and here I will say PR equal to PR multiplied with P, right? I will keep increasing the power of this PR na. So like it's similar to factorial, right? Like instead of calculating the same power again and again, so it's something like this. Let's say if I need the 31 raised to power 5, right? But in previous iteration I calculated 31 raised to power 4. Then why I should calculate this all the powers again and again? So instead I will keep saving it in a variable. So initially PR will be 1, that is 31 raised to power 0. Next time PR will be 1 into 31, so it will be 31 raised to power 1. So whatever be the PR is, PR star equal to, it will be 31 raised to, multiplied by 31, right? So I'll keep getting the value 31 raised to power 1, 31 raised to power 2, 31 raised to power 3. So yeah, it's the same, similar to the factorial logic, like why to calculate the whole complete powers again and again, right? So this is one optimization we can do here. And also this power could go long, right? So let's take a mode here as well. So I'll take a mode here as well, right? So it will give me a mode value here as well, right? So let's so this way it will be a little bit more effective. So if we try running the code again, though right now we are doing this thing in here, okay, there should be a semicolon. So in bigger test cases, we'll be able to see the difference, how fast we are getting to the same value, right? But this way it will be much more faster. Okay. Okay, so now, let's say we have a problem, and what we need to do is we need to count distinct substrings, okay, in a string. So, like here we see, right, we earlier see how we can store the different substrings in a set, right, and then we can print the simply set dot size, right? We can simply print the set dot size. But here instead of saving the different various substrings, we will be saving the corresponding hash values, right? So all the unique hash values will get saved, right? And we will print the count. Okay, so now we will use this hash thing, we will use these hash values to count the substrings. Okay, so let's create a function. Let's say int distinct sub str, right? And here again you will be given a string s. Let's say you will be given a string s. So what I'll do is I'll do the same things as is earlier. So I'll create a set here as well. but this time this set will be of type integer. So we will be having a set st. Then let's say we have this int n equal to s dot size, right? We have this n equal to s dot size. Then again we will run the same for loop int I equal to 0, I less than n, I plus plus. Then instead of now this sub str, we will be having the hash, right? So we will be having the int hash, right? Let's say we will be having this int hash equal to 0. So let's declare this here. Let's say int hash equal to 0. We have this hash equal to 0, and now we don't need anything like a string sub str or something. We will go inside the inner loop. Let's say int j equal to 0, j less than n, j plus plus. So for every substring, now for every substring, we need to calculate the hash, right? We need to calculate the hash. So for calculating the hash, we can simply use the same formula. We can simply use the same formula that we used in the this function, right? So we will be having our set here, right? And then just one more thing that we need to do is we need to do the st dot insert. So we will insert our hash value into the set, right? So we will insert the hash value within the set, and then what I'll do is I will in the end I will return st dot size, the size of my set, right? So I'll simply return the size of my set. So this way I'll be able to have all the values, right? And one more thing here. Okay, so we will be needing the p value, right? So we will be needing the p value because let's directly write 31, because here we are passing this p in the function. But here let's anywhere else we are using p. No, 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 no. So and also we need to declare this pr variable as well here as well, so that this int pr equal to 1 for the powers. Anything else? Hash we have prp, yeah, old set. I guess we are good to go. So this way we will be able to print all the distinct substrings, right, in n square. And also we won't be getting a mle, that is the memory limit exceeded, because storing a integer is not that much hectic of a task or difficult of a task, you can say. So so this time we are not going to get the mle because we are storing the simple integers, right? Now, let's just say you are trying this, let's say in code forces or somewhere. Let's say you are getting error, you are getting your answer is wrong. Let's say your count is not getting right. Okay, so let's say your count is not getting right. Let's say you are not getting the unique hash values for different sub strs, right? You are not getting the distinct hash values, right? So now what we can do is instead of taking a single hash values, we can take pairs, right? Because one hash value may match, but there is a very less possibility that a pair will match for the same substring, right? So what I'll do is instead of let's take a pair here, right? Let's take a pair here. So int comma int, right? So let's take a pair here. Now what will happen, let's say we have a hash one, and let's say we have a pr1, and let's just copy, let me just copy this thing and let's just paste this thing. So let's say we have a hash one, we have a pr1. Let's say hash 2, we have a pr2. Then let's say here we have a pr1, here we have a pr2. And let's say here we have this 31. Let's take here a different value, let's say 37. Okay, let's take a different value 37, and here in st dot insert, what I'll do, I'll simply insert hash 1 comma hash 2, right? So I will, instead of inserting a single value, I'll be inserting a pair hash 1 and hash 2, right? Now there is a very less chance, like a pair, we are generating two hash values for the same substring. So there will be two unique integer values, and there is a less chance, it will be 1 upon mod square probability, right? So that is a very like negligible chances that the hash value for two string will match, right? So it will obviously increase the accuracy. Unless and until you are getting an error, just don't do this thing, don't do this pairing. Just do this if you are getting the count is wrong, right? Because then there is a possibility that the hash value for two substrings is matching, but this way you will be able to get your answer correct, right? Okay, so I guess the video length is already very large, and the upload may get stuck. But in next video what we'll do is we'll do some very good level questions, like there is good substring, so we'll see how we can use the rolling hash functions. It will be obviously 1800 star question, so no doubt it's a really really good question. So we'll try, two three very difficult problems on strings. Okay, so totally based on the rolling hash functions, how we can solve with this. Then we will be learning something called as Robin algorithm. There is KMP algorithms, right? So we'll be learning them as well. So just stay tuned and connected. I'll see you in the next lecture.